All right, we're looking here at Math 7, Unit 1, Lesson 6, Scaling and Area. And today in class you probably work some various shapes to start talking about and figuring out how scaling, when you scale a shape, how that impacts a shape's area. And this is a little bit of a complicated lesson. It takes a lot of practice working with visually what's happening with different shapes as you move from one set of shapes to another and try to change the sides and things of that nature. So for example, you probably began with something like the rhombus shape here. And in the rhombus shape, what was interesting was if you took the rhombus, and then look at get my nice picture here. There we go. We took the rhombus and you said, okay, what's it going to take to go for each side is twice as long? You might have had a chance to do this with your blocks where you said, well, if I want it twice as long, I want to go double this and double this length. And so if you add, we notice that to go twice as long, it actually took 4 blocks to go twice as long. If we wanted to go 3 times as long, well, then we have to add another one and another row up top as well. And so we end up going 9. And so the pattern seems to change quite a bit. So if we had, for example, back to our paper here, if we looked at just A, if it was twice as long, we ended up needing 4 blocks. If it was 3 times as long, we needed 9 blocks. If we wanted to go 4 times as long, we would need 1, 2, 3, 4, 5, 6, 7 more for a total of 16 blocks. So even though I started with 1, there's a definite increase as I move up for how many more blocks it's going to take to go from shape to shape. You may have done that same thing then with a triangle. You can take the triangle if you start with 1, a triangle here, and you go twice as large. You go 1, 2, 3 for a total of 4 blocks there, the triangle. 3 times as large, we add another row on the bottom to get our 1, 2, 3 times as large base. But I want to make sure that I'm 3 times as tall. We end up with 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks there. And we notice a nice pattern emerging, don't we? If I want to make it 4 times as long and increase that, we end up with 16. And so without even messing with number C, we probably have the same pattern there, which indeed you did. And so that's what we saw with the blue rhombus, the green triangle, the red trapezoid, kind of working those things. There's definitely a pattern for what happens to the number of blocks used in the inside. And we call that inside space the area. So that's the area and what's happening with the area. So every time we're changing a scale factor, the scale factor, whatever that might be, twice as long, 3 times, 4 times, that scale factor has an impact on the overall area as well, which is what this lesson was about. You might have had some time then to take a look at some more pattern blocks here. And the pattern blocks were very interesting to try to take the groups, the ones you had. You might have had these 3 or 2 of those or 4 of those, various shapes there. And you were asked then to use those shapes to then make some new shapes, to build a scaled copy of your assigned shape. And to say, well, we do if a scale factor is 2, that means we're going to double the length here to make this work. We're going to come out another length there, going to come out another length there. But that doesn't mean I'm done quite yet, because I still have to continue this and go another one there, another one there, as so, and another one here, and another one here. But then I have my triangles, my diamonds here this way, until you get this scale factor of 2 looking something like so. And so if you were to work that out, and this one's a little bit the other direction, see if I can make it that head there. So the idea is that we took our initial one and we had to go out and extend it to go up 2 to make that spread out a little bit more. But we went from having 3 on the inside to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We went from having 3 to having 12 in terms of our area. A similar thing happened when you went to the one over here, F. And when you had F, you had a shape that looked something like this to begin with, where you had the 4, and to double it, we had to go all around the sides, and we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We went from 4 to 16 when we doubled that in size there. And so there's just this constant pattern type of thing that keeps happening as we are working with the scaled copies and we are finding what the areas are going to be. And if you do this enough times, let's take with the first one here, letter D. D had an area, original area right? So our area initially with D was 3, right? But if I had a scale factor of times 2, we found that our new area was 12. Now if I took that and said, well, let's do a scale factor of 3, our area became, and you work this out with your class, 27. And if on this one you were to continue to go, scale factor 4, scale factor 5, and scale factor 6, and as you continue that pattern, we had 48, we had 75, and we had 108. And what was essentially happening was this. We kept taking our original value and multiplying it by, this is where it gets a little fun here, by the scale factor squared. Or here it is again, 3 times the scale factor 3 squared. Because 3 squared is 9, and 9 times 3 is 27. So if I take the original value and I multiply it by the scale factor squared, I end up with my new area, or what's going to be right here, my new area. So what's happening is this, is I can essentially say my new area is going to be my original area times the scale factor squared. So when I'm doing a shape, what's going to happen to my new area is I take the original area and I multiply it by the scale factor squared. Make sure you do the order of operations first, do this first, and then we can multiply that and we're good to go there. Alright, you did some more of those with your class and your group work there, and you eventually got to having some different shapes, and you might have had a shape like the one right here. We had a parallelogram, and they said, well, this parallelogram, and there were a couple shapes here. You could have a parallelogram, you also could have had a, if I'm not mistaken here, triangle like so, where you had 4 and 5. With a parallelogram, you had a base of 5 and a height of 2, and because you would do length times width to find the area, you end up with an area of 10. And you put that down there. To do the scale factor for this problem, what you're looking at then is saying, well, the scale factor is going to be, if I'm going to do it times a multiplication of times 2, then my base becomes 10 and my height becomes 4. My new area becomes 10 times 4, which is 40. Same for 3. 5 times 3 is 15. 2 times 3 is 6. And 15 times 6 is 90. And then if I have fractions, I have 5 over 2. 2 over 2, which is 1. And then I can multiply that out to have just a 5 over 2, or perhaps you made it a fraction, which is decimal 2.5. And for this one, I'd have 5 times a third, which is 5/3. 2 times a third, which is 2/3. Multiply that out, and I have 10 over 9. So I could have worked it out that way for this shape here. And when you play with the triangle, you found the triangle had the same area as you moved along and did everything for the triangle, because again you had a base, this time you had a base of 4 and a height of 5, but the formula for triangle is 1/2 the base times the height, so you end up with 1/2 of 2 times the height of 5, and so there you go. So that is your, am I in the right spot here? Looking the right, no, sorry, 1 second, 5, 4, yeah, we're okay. Alright, so your triangle works the same way, and we'll move on from there. So you're comparing those things, we're looking at the scale factor, and again, the point here we're looking at is that as we went along and did this, if we drew the scale copies and we wanted to compare areas, what we found out again and again was that our original area times a scale factor squared would tell me what my new area was going to be. And so as a way of summarizing this lesson here, and again, hopefully you spent a lot of time with this, the point was that scaling affects lengths and areas differently. It all affects things differently. For a scaled copy, we can take a length and say, well, it's 2, and to get to 3, it's times 6, it's times 3, and that's pretty easy to do. But the area of the copy changes by a factor of the scale factor squared, and this is really important. So when we look at this one, for example, even though we just go from 2 to 6 is times 3, for the area is different. We take that scaled factor, 3, and we're going to square it. So 3 squared is 9. So you take a look, we had 1 square right here, and here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 rectangles make up that new shape. So instead of just 1, we have 9, and that's how we get our different area, and the way those things are going to be there. Again, that's not the actual area is 9, but we end up with 9 squares instead of just 1 square because of that scale factoring like so. Okay, so the lengths are one-dimensional, so in a scale copy they change by a scale factor. Area is two-dimensional, right? Length and width, so it changes by the square of the scale factor. Let's take a look then at tonight's homework and see if you're on the right track there with tonight's homework. Okay, so first of all, we had a shape here. It says on the grid, draw a scaled copy of polygon Q using a scale factor of 2. So with a scale factor of 2, that means I'm going to be multiplying the lengths and the widths all by 2 is the idea. So I'm going to start with my corner, and my corner I started with 1, 2, 3. So I'm going to just go ahead and start right here. So instead of 3, I'm going to do 3 times 2, which is 6. So 1, 2, 3, 4, 5, 6. So that's going to be 6. This one was 2. So because the scale factor is times 2, I'm going to go 2 times 2 is 4. 1, 2, 3, 4. And we're good there. This was a length of 1, so times 2 becomes 2. 1, 2. This was a length of 1, so I'm also going to go 2. 1, 2. For the length here, we had 1, 2, 3, 4, 5, 6 again. So I'm doubling that, so instead of 6, I'm going to have 12. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go all the way out there to 12. For this little height here, this run vertically, I had 1, so I'll go up 2, 1, 2. Here I had 1, 2, 3, 4, so 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. And as you can see, I ended up at the same point there, and that's a 2, so it should be 4. 1, 2, 3, 4, and we're in good shape right there. Alright, so that's an idea of what that scale factored shape would look like with a scale factor of 2. When I compare the perimeter, what that means is if I add up the lengths here, this perimeter has, if I start at the 3, I have 3 plus 1 plus 4 plus 2 plus 6 plus, don't forget this one here, 1 plus 1 plus 2. So in this area, in this perimeter here, perimeter Q, I end up with 20 when I add all that up. When I do this perimeter and start at the bottom here, I have 6 plus 2 plus 8 plus 4 plus 12 plus 2 plus 2 plus 4. And when I do this one, what I find is that the perimeter of the scale factor 4 is a lot larger, isn't it? Right? So I could kind of do some little quick math. 12 plus 8 is 20. Here I have 30. And here I have 34, 35, 36, 37, 38, 39, 40. So this one is 40 for the perimeter. So perimeter here is 40. Perimeter here is 20. In terms of the area, that would be counting up all the little squares that are inside of that shape initially. Okay, so the perimeter, this is 20, and the area here happens to be 16. There's 16 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my area is 16. Now what we said before is that to find the area of a shape, we could take the original, right, the original area times the scale factored squared to get my new area. So in this case, my original area was 16, and if I multiply that by the scale factor, which is 2, and that is 2 squared, that should give me my new area. Well, 16 times 2 squared is 4, and 16 times 4 is going to be 64. So my new area should be 64. Now, just to verify that, we can check it out. We can count them up. 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20, 40, 60, 61, 62, 63, 64. So we do indeed have an area of 64, and we're looking good there. So our little formula here worked. We take the original area times the scale factor squared, and that gets us our new area. For number 2, it says that you have a right triangle has an area of 36 square units. So we have some kind of triangle with 36 square units. So it might look like something like, it doesn't matter what it is, but we have a triangle, right triangle, and it says the inside area is 36 square units. This is what we're looking at. All right, so what's happening here with our shape? If you draw scale copies of triangles using the scale factors in the table, what will the areas of these scale copies be? Explain or show your reasoning. What we said before is that we take our original area and multiply it by the scale factor squared, and that gives us our new area. All right, so because we have our original area of 36, we can say, well, if that's the case, I can take the original area 36 and multiply it by the scale factor squared, which is 2 squared, and that's going to tell me my new area. And so 36 times 4 ends up being 144. All right, getting the idea there? Let's skip down to one of these over here because you can use the same pattern. I'm going to do it one fraction one. If I had the original area times the scale factor of a half squared, well, let's pull this over here to take a look. This is saying 36 times 1/2 times 1/2. A half times a half is 1/4. So I really have 36 times a fourth. Well, 36 over 1 times 1 over 4 is the same as 36 over 4. And I can figure out that there are there's 1 4 in there, and there are 9 4s in there. So I end up with 9. 36 divided by 4 is 9. And I can do the same thing down here for these other fractions. I'm going to let you solve 3, 5, and 2/3 on your own using this same kind of formula. Take your original, multiply it by the scale factor squared, right? Scale factor squared, and that will become your solution. Moving to number 3. It says Diego drew a scaled version of polygon P and labeled it Q. So there was something before and we went from P to Q. If the area of polygon P is 72 square units, so it was 72 to start with, what is the scale factor he used to go from P to Q? Well, let's take a look at Q. Q has 1, 2, 3 whole squares. And then it has this little part of a square, and this guy here, if we were to flip that and cut it out, matches right there. So that becomes our fourth one, and then we have a half. So we went from 72 to 4.5, didn't we? A little different, right? 72 to 4.5. So it wants to know the scale factor. What's it take to go from 72 times what scale factor is going to give me 4.5? That's the question we're trying to ask ourselves. Okay? So to solve this here, a couple ways I could do this. I could think about it as 72 times the scale factor, this is area, scale factor squared. I think I didn't say it before. So scale factor squared is going to equal 4.5. I could also say that it's going to be equal to, instead of 4.5, I could say that it is 4.5. I could say that it is 9 over 2. Depends on what you want to work with there. I know a lot of you guys like to put things into decimal form. I actually prefer fractions. So I'm going to do 72 times the scale factor squared equals 9 over 2. I want to do that because I want to go ahead and multiply by the reciprocal here. So this becomes 1 over 72 times 1 over 72. And I can reduce here. 9 goes in 72 8 times. So I end up with 1 over 2 times 8 is 16. So my scale factor squared is 1 over 16. Not done yet because of this square thing here. So I have to think to myself, what two numbers can I multiply together to get 16? Well, I could do 1 times 1 to get 1, but I can also do 4 times a 4 to get 16. That's what squaring means, right? So my scale factor will just be one of those, and so my scale factor ends up being 1/4 for what Diego did here. Okay. Here's an unlabeled polygon, number 4. Along with its scale copies polygons A to D. For each copy, determine the scale factor. So we're looking at this shape right here. We're looking at what happens from the original. Here's our original. From this one to A to B to D. Okay, so for A, what's happening from A? We're moving from having 2 units, right? 2 units there, down to 1. So because I'm going down by 1, we would say that what's going on is we have a scale factor of a half. We're reducing it by a half, multiplying everything by a half. For B, we have 1, 2, 3, 4. So we're going to be increasing from 2 to 4. So how is that going to take place? That scale factor is going to be times 2. Right? So times a half times 2. C is a little bit different, but again, we've probably seen it like before. We go from 2 to 1, 2, 3, don't we? Now, if we're not sure, we take the new divided by the original to find out the scale factor. That equals our scale factor. Oops, ran out of space there. And so in this case, my new one was 3, my original was 2, and so our scale factor is times 3 over 2. And finally, our last one, we have 1, 2. It's the same, and so our scale factor is simply going to be 1 for letter D. We have some mental math questions here for you to solve. For number 5, just thinking about how I can get a 1. Again, this would be looking at if I have 1 over 7, to make that into a 1, I multiply by the reciprocal. Over here, same idea. If I have a 1 over 11 here, then I want to make the x 11 over 1 to multiply by the reciprocal. And then over here, I want to have 1 divided by 1/5. That one's a little bit different now, isn't it? What am I going to do with this one? Well, 1 divided by 1/5, it becomes simply 5. And so to do that, I can not worry about the 1 too much. I multiply by the reciprocal, and we end up with 5. Alright, I'm going to leave it there for now. I'm going to let you kind of ask some more questions to your teacher when you get back to class. Hopefully it helps you out a little bit with today's lesson.